Welcome again to another one of my mathematics tutorials. In this session, we will be looking at linear programming. Now, what is linear programming? It's actually a method that is used to determine the best possible solution or outcome from a given set of parameters, right? And it is usually represented in the form of linear relationships. Now, to better understand that explanation of what linear programming is, let's delve right into our question. So here I have one of the questions taken from a CXC book. The owner of a store wishes to buy X radios and Y televisions to sell to the public. Okay, so we know that the number of radios and the number of televisions is unknown, right? They used X and Y to tell us the number of radios and televisions. The total number of sets must, however, not exceed 20. Now, what that simply means is that the total number of radios and televisions put together cannot cross 20, right? So it could be 20 or less. He buys each radio at a cost of $150 and each television at a cost of $300. So each radio costs $150. Remember, radios are X and televisions are Y, right? So each radio costs $150 and each television set costs $300. But he spends no more than $4,500. So when you put the total cost of the radios and the televisions together, he cannot spend more than $4,500. So it means that he can either spend $4,500 or less. He also buys at least 5 of each set, right? So at least 5 means 5 or more. So in terms of the radios, he has to purchase 5 or more radios, and in terms of the television sets, he has to purchase 5 or more. Now, before we try to answer part 1, which is to write down 4 inequalities which satisfy the given information, I just want to look at some inequality signs and make sure we thoroughly understand the signs and what they mean. Okay, so here I have written some of the inequality signs. So the first sign is more than. And a word that they tend to use when referring to more than is exceeds. So if they say the number of radios must exceed 10, it means that the number of radios can either be 11, 12, 13, etc. Less than. This is our less than symbol. This symbol here is more than or equal to. And a word they tend to use to refer to that is at least. So if they say at least 10 radios, it means that it can either be 10 or more, right? At least meaning 10 or more than 10. Next, we have our less than or equal to sign. And sometimes they will say no more than. So if I say no more than 10 radios, it means less than or equal to 10 radios or does not exceed. So the number of radios does not exceed 10. It means that it has to be less than or equal to 10. So now let us try to write down the 4 inequalities that is going to satisfy the given information. So the owner of a store wishes to buy X radios and Y televisions to sell to the public. The total number of sets must, however, not exceed 20. So the total number of sets cannot exceed 20. So that's our first inequality there. X representing the number of radios and Y representing the number of television sets. These two put together, meaning the total number of sets, must not exceed, so it has to be less than or equal to Remember, the words less than or equal to can also take the form of does not exceed. So we have less than or equal to 20. And that's our first inequality. Let's continue. He buys each radio at a cost of $150 and each television at a cost of $300. But he spends no more than $4,500 on the sets. Now, we know that $150 is the cost of a radio and $300 is the cost of a television. Now, he purchased X radios. So if he purchased X radios and the cost of one radio cost $150, it means that 150X is going to represent the total cost of the radios. And 300Y is going to represent the cost of the total number of televisions. So they are saying that it must not exceed or no more than $4,500. So this has to be less than or equal to 4,500. So the total cost of the radios and the televisions is no more than 4,500, and that is our second inequality there. Next, he also buys at least 5 of each set. So in the radio, he buys at least 5. So at least, if we go back to up here, we are seeing that at least means more than or equal to. So X has to be more than or equal to 5, as well as Y has to be more than or equal to 5. Right? So he also buys at least 5 of each set. And that there is your 4 inequalities. Next, part 2, graph the system of inequalities and shade the solution set. So here I have my inequalities and now I need to plot them on my graph. So I'm going to start off with the first inequality. X plus Y is less than or equal to 20. Now in order to do this, I need to pretend that I have an equation that I am working with. So X plus Y is equal to 20. Remember, to draw the graph of an equation, I need to substitute some X values or Y values and in turn work out for the missing variable. So what I'm going to do is I'm going to choose the X value 0. So when X is 0, it will mean that Y is 20. So I have my first pair 0 and 20. Next, when Y is 0, so I'm going to use Y as 0 now. So it's going to be X plus 0 is equal to 20. And I can see that X is going to be equal to 20. So I have my second pair of points. And remember that all you need is 2 points in order to draw a straight line. Right, so I'm going to plot these points 0, 20, so 0 on my X and 20 on my Y, that is going to be here, and 20 on my X and 0 on my Y is going to be here. So I now have to draw a straight line that connects those 2 points. Alright, so that's my line there that represents the equation X plus Y is less than 20. So it's X plus Y is less than or equal to 20. Now remember that it's an inequality that I was working with, right? It's X plus Y is less than or equal to 20. Now, because my sign has an equal sign with it, I have to draw a solid line to connect those 2 points. If, however, my inequality sign was less than or more than, so let me write it here, a less than or a more than sign without that equal part underneath it. So we did not have that equal part underneath it. If it was just less than or a more than sign, my line would have had to been a broken line, right? So it would look something like this, where parts of the line missing, right? A broken line. But because my inequality had an equal sign with it, it needs to be a solid line. Now, it's less than or equal to. So to represent less than or equal to on my graph, it's going to mean that I have to shade everything under that line. It's less than or equal to 20. Okay, so I have finished plotting my first inequality. Let's move on to the second one. 150x plus 300y is less than or equal to 4500. So I'm going to do the same thing. I'm going to choose x as 0 and work out what y is. So 150 multiplied by 0 plus 300 by y is less than or equal to 4500. And remember, in order to put this on a graph, we will pretend that this is an equation we are working with. So it becomes 0 plus 300y is 4500. So we are going to get y is equal to 15. So now I have my first point, x being 0 and y being 15. I'm going to take back my equation here, and I'm going to use now y being 0. So it's going to be 150x plus 300 by 0, and that's going to give me 0. So I'm going to end up with 150x is equal to 4500, and I know x is going to be 30. So my next point is going to be 30, 0. So let me plot those 2 points. 0, 15 is going to be here, and 30, 0 is going to be here. And then I connect it with a straight line, and that's it there. Remember, this is the line 150x plus 300y is less than or equal to 4500, right? And it's less than or equal to, I have that equal to part there, so my line is a solid line, and it's less than, so I need to shade under that line. So I'm going to use a different color. So I have shaded under that line there. Let's move on to our third inequality. So I'm just going to tick this to indicate I'm finished with that. So our third inequality is x is more than or equal to 5. And that's a pretty straightforward inequality. X is more than or equal to 5. What I will do is I will locate x being 5 on my graph, and that's at this point here, and it is going to be a vertical line through 5. Now, why is it a vertical line through 5? Because anywhere on this line, I am going to notice that my x value is 5, right? So it's more than or equal to, that means my line has to be solid, and more than or equal to 5 is going to mean that I have to shade everything to the right of this line. All right, so let me just write here that this is the line x is more than or equal to 5. Let's look at the line now. Y is more than or equal to 5. And that one is also straightforward. I look for the value where y is 5 on my y-axis, and here it is. And I draw a horizontal line through 5. Right, so that's my horizontal line there through 5, right? And remember, it's a horizontal line because any point on that line, you are going to notice that the y value is going to correspond to 5, right? And we have our inequality being more than or equal to, so it's going to mean that I shade everything above that line, right? Now, my graph looks a bit complicated, but don't worry about that. Let's refer to the question, part 2, which is to graph the system of inequalities, and we have just done that, and shade the solution set. So now we are going to shade the solution set. Now the solution set is that part of your graph where you are seeing all of the colors. So notice I used red to indicate that first inequality there. I used blue to indicate that second one. I used, I believe it was green to indicate this one here, and I use that multicolor one to indicate this last one here, right? So we are going to examine the graph and look for that part where we are seeing all of the colors. So I'm just going to enlarge this, and you are going to notice a part of the graph with all of the colors. So let's take a look at this part here. I'm not seeing any green in this part here. Let's look at this part underneath here. I'm not seeing the multicolored color underneath here. If I look on this side here, I'm not seeing any red. But if I look here, in this region here, I am going to notice all of the colors. So I'm going to take my highlighter now, and I am going to highlight that part of my graph where all of the colors are noticed. So it's this part of my graph that has all of my colors, and that there is going to be my solution set. Now notice the shape of that solution set, right? It's actually a four-sided figure. 1, 2, 3, 4. It's a four-sided figure, right? So that's a quadrilateral there. Now what I want you to do is to take the vertices, and I'm going to use my black here. Take the vertices of that figure, right, that quadrilateral. So I'm going to take that point there, I'm going to take that point there, here and here, and I am actually going to write the coordinates of those vertices. So for this one right here, the coordinate is going to be 5, 5. So I'm going to write that here, 5, 5. This one on this side here is actually going to be 15, 5. This one here is going to be 10, 10. and this one here is going to be 512. Now, these points are going to be very important when we are trying to work out that last part of the question. Part 3 says, if when the store owner sells the sets, he makes a profit of $100 on each radio and $120 on each television, determine the maximum profit, the maximum possible profit, and the number of each set he must sell to obtain the maximum profit. So what I will do is I'm going to write a statement for our profit. So our profit is going to be 100 on each radio that he sells, and remember the number of radio he sells is X, and $120 profit on each television that he sells. So the total profit is going to be 100x plus 120y. And now we are asked to determine the maximum possible profit and the number of each set he must sell to obtain the maximum profit. So this here, profit equals 100x plus 120y. I'm just going to write that here. So my profit is going to be 100x plus 120y. And I am going to take each one of these now and I am going to substitute them into my profit equation here. And I will work out what is going to be the maximum possible profit he could get and how much of each item he must sell in order to get that maximum profit. So it's going to be 100. I'm going to use this first pair of coordinates. So it's going to be 100 by 5 plus 120 by 5. And that is going to give us 500 plus 600, and that is going to give us 1100. Now, what this is simply telling us is that if he wants to make $1,100 profit, he's going to have to sell 5 of the radios and 5 television sets, right? So let's see for the next pair. I'm going to use this pair now. So it's going to be 100 multiplied by 15 plus 120 multiplied by 5. And remember, I'm using this profit equation here. So it's going to be 1500 plus 600, and it's going to be $2,100. So it means that if he wants to make $2,100, he's going to have to sell 15 radios and 5 television sets. Let's look at the next one. 100 multiplied by 10 plus 120 multiplied by 10. And that is going to give us 1,000 plus 1,200, and that is going to give us $2,200. So if he wants to make $2,200 profit, he needs to sell 10 radios and 10 televisions. Now let us look at this last point here. We are going to substitute that. So 100, remember we are looking at the profit equation here, right? 100 multiplied by 5 plus 120 multiplied by 12. So we are going to get 500 plus 1440. and that is going to be 1940. So I can see that this here is going to yield the most amount of profit. So to answer that question above, where it asks us if when the store owner sells the sets, he makes a profit of $100 on each radio and $120 on each television, we are asked now to determine the maximum possible profit, and we are seeing that the maximum possible profit is $2,200. So I'm going to write that right here. It's $2,200, and the number of each set he must sell to obtain that maximum profit. So he must sell 10 radios and 10 televisions. And that there is how you answer a question on linear programming.
Don't forget to like, share, and subscribe for more of my videos.